stars is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all seems with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Hey everybody, welcome to SkyTour live stream. Believe it or not, we're here, we're live, we're cranking. It's a great night out there. It's so utterly clear out there that it's just incredible. So we're really looking forward to tonight. Right now, I'm just trying to get Daryl back with us because he was here and then he disappeared, but it's okay. We'll figure it out. All right. Let me give him a ring, and I'll let you know what's going on here. So this is Sirius we're looking at right here. That's what you're seeing right there. Okay. And Sirius is just a beautiful star in our sky. And I have Daryl back with us, so I'll bring him in here in just a second. Because as always, you know, it's fun to have Daryl with us and hang out with us. Daryl, how's it going and how are you doing? Let me bring you up here. You should.
Share the screen.
Yeah, you are. I know. You'll be here with me now. All right. So Daryl's with us again. Hi, Daryl.
Hello, Mark. Hello, everybody. Long time no see.
I know. It's just not. Hasn't been that long, but it's been long enough, hasn't it? Yeah.
More than long enough.
Yeah. That's.
I blame it on El Nino.
Actually, that's a. It's actually a good thing to blame it on because it's actually been pretty bad, and has caused us a great deal of trouble. But you know something, it's okay. It's all right because we are actually cranking away now. We got big changes coming for SkyTour Livestream. We've got a few amazing opportunities coming our way that hopefully will make themselves obvious to us, as obvious to all of you as we move forward. We are going to be changing our entire telescope system. You see right here, we're going to have the same telescope barrel, but we're changing that whole mount system. We're going to get a mount that's going to be far more reliable, and then we're going to actually buy two of them, and we're going to put the telescope in Benson, Arizona on the same exact type of mount. And this will allow us to look at objects in the sky the same exact way that we do from both telescopes, and that will make it easier, for instance, when we want to actually show two screens where you're seeing the Benson view and the Sonoran view. So this is SkyTour Sonoran, and we'll have SkyTour Benson, and SkyTour Terryville, the East Coast one, that's going to be our solar telescope. I have the solar telescope here, and I just need the mount for it, and the enclosure, and we will have a live solar telescope to view the sun all day long. And so that'll be a stream that's continuous during every single day. And that one is going to be coming up probably concurrently with the Benson telescope. So we'll have three. And I may have some connections to folks in Australia. And the Australian contingent for STLS might be something that we'll be able to do too. So we can start looking at Southern Hemisphere objects for the first time. And that's news I don't think you've heard, Daryl. So
News to me.
yeah, exactly, and that's good, you know. And so I'm pretty sure, that we'll be able to do that, you know.
Benson, Arizona is not in the Sonora Desert too.
What's that?
Benson, Arizona. That's not also Sonora Desert.
Oh no, that's 150 miles southeast of this.
Okay,
Skies are 0.01, and then there's some units darker rather than where we are now. So the sky is actually 0.01 darker, which is kind of cool. You know?
I thought that was all the same desert down there.
No, not at all. This is far east of Tucson, where we are going to be with Benson, and this is far west of Phoenix, which is 2 hours north of Tucson.
I understand. There's saguaro cacti growing both places, isn't there?
As a matter of fact, yeah, the Saguaro National Monument is down in Tucson. Okay, there's, it's different, and so this area that we're going to be in Benson, even though there's more buildings in the local area, we're still not anywhere near paved roads yet, which is fine. I prefer that, to be honest.
Hope it'll keep the yahoos away.
Yeah, and the security systems will also do that, but or help to do that anyway. So I'm trying to just get us this is serious, as I mentioned, and I'm trying to just bring us up now. It's just I noticed in the chat earlier someone said, "Is it dark enough?" And the answer is not quite. If we take a long exposure, then it might not be. Let's see if we can go to the little beehive here. But before I do that, actually, I'm going to do one other thing here. I'm going to lock us onto Sirius here and do what's called a synchronization. And we're still waiting for Starlink. The thing is about Starlink, which is really interesting, is that in our location here, our location with Starlink here is fascinating because it's actually we're actually a low bandwidth site for Starlink here, which I think is pretty fascinating. We're considered low bandwidth. Which I don't like, but, it's only because there's not enough Starlink satellites for complete coverage yet. Okay, we are synchronized. So I will come down here now, and we'll just... What's that?
Oh, I laughed. There was a really cool picture of Comet Pons Brooks on spaceweather.com, the one I sent to our group chat.
Yeah.
The one I didn't send, there was another one. A guy took a 25-minute exposure of the comet, and it was just absolutely riddled with Starlink satellites.
I bet it was. Well, there is this little beehive, and we're going to come in here. I haven't focused yet, so I'm going to be doing that with this right here. So we're gonna use this particular cluster to do our focus. This is critical focus, where we actually will grab a focus adjustment for this particular location. You can see they're out of focus. And now, even so, we have 21 stars recognized. Now we're going to go inward, because we're going to stick around in this region for a little while. And then we're going to move out and go further up north.
Curtis Horn has a question of you.
And I'm seeing it now. It says, Mark, I'm curious if you heard that a few cosmology studies found in the last couple of years that large-scale structures seem to violate parity symmetry. Yeah, I have seen that, Curtis. And to be honest, I actually don't know what to make of that, to be fair. I recognize that cosmology is still, believe it or not, a new science. In fact, as well as an understanding as we have, we're not really certain of our cosmological origins, are we? And I think Curtis in the chat here is someone who would be willing to admit that and talk about that right up front. Curtis, are you going to be at Contact in the Desert in early June, first weekend there in June, the first few days in June? Because I'm going to be there. I'm going to be speaking about Kaluza-Klein gravitons and things. So I'm wondering if you're going to be there. Because then we can sit down and talk and fly over the heads of everybody around us, I guess. But I think it'd be pretty cool if you're there. Let me know. There's our focus position. Hello, James Hyatt and the others. I saw a bunch of people here. I was actually really quite amazed by how many people were already here. But we have Renee Cruz joined us. Tim F. is with us. Calabos came in for a little bit. He works at Starlink, and he's actually moving over to a different place within SpaceX, I hope. And Sean is here. How you doing, Sean?
Izabela's here.
Izabela did make it. Excellent. Thank you for coming, Izabela. I hope you got my little alarm clock message I sent you in Skype. Rastley Rabbit's with us. Donald Kunzer's with us. Michael Hedrick, what's happening, brother? And Daisy and Zoe Amethyst are here. And, lots of rain here, too, actually, in Connecticut. But none out in the desert. And I just love that. Okay, let's grab our focus.
Finally.
Yeah. Okay. And now we are critically focused. So we will shut down the focus thing. Look at that. All right. Now let's do this. We're going to take a 15-second exposure. That's 15,000 milliseconds. And we're gonna see what that brings us, because, and I'm gonna reduce the night vision setup here and just go looking in our stack. You can see down there, this is our setup. You can see our actual, let me give it a little more room there. There you go. You can see the yellow bar, and when that comes in, it'll stack, and you'll see our first image if it passes our filter, and it does. So we can do this, and the reason I'm doing this is to see if it has a little red tinge to it, and it doesn't quite. So I think that we're good with the night sky in terms of having the sunset bothering our imagery. But look at this beautiful cluster. That's really pretty. So let me finish saying hi to folks that are here. Michael Hedrick says the intro with the Andromeda Galaxy without stars is awesome. It is kind of interesting to see it without the stars. In fact, that's how we process everything, is we do it without the stars. And that's kind of cool. You know, that's really kind of cool. So, neato. And elsewhere in here, I gotta see if Curtis responded to me. Papa Tom's with us. Hey, Papa Tom. Good to see. Oh, Curtis Horn says he's behind on the stream. Have made summer plans. I'll keep it in mind. All right, cool. Very cool. Yeah. It looks like Monday I'm going to go on the InfoWars network again. They asked for me to come on again because they want to talk about the eclipse. I'll be going on in the morning. I did an eclipse talk last night, and I had a full house. It was great. You know, a lot of people are interested in the eclipse anyway. So
I've been hearing late weather reports, and I think no matter where you are, there's going to be people disappointed. I hate to say that, but you know, it always happens.
Mm-hmm.
I'll just be staying home and watching the partial from here.
Yeah, we're gonna have 92% coverage here.
Yeah.
And at 92%, even though the sun is very bright, with proper photography, you can actually see on the other side. You'll be able to see some of the corona with 92%. It's subtle, but you can see it. So it's a possibility. Hey, Dude W's with us. Hi, Dude. Yeah. All right. This is pretty. We have to look at this cluster and see how many of those stars, if it's a mature cluster, probably a mature cluster, because it already has some potential red giants in it, I believe.
Yeah, see them there.
Yeah, if they're in there, most likely they are. You know, because this is kind of a rich area, but you don't see too many out here, but you see some really bright ones kind of in here, and just like with, you know, the double cluster. So the likelihood that you have these stars clustered together independently of a cluster behind them is kind of rare. Yeah, Curtis is talking to me about doing his talks on APEC. Yeah, that's pretty cool. You know, and I need to stress that I think that in order to understand how any potential extraterrestrial life is here, they're certainly going to end up using rather unconventional methodologies. My personal feeling is they're not using any propulsion. They don't use propulsion. I think they just generate these Kaluza-Klein particles, and they dimensionally shift into the fifth dimension, that dimension called the bulk. You know, and so they basically just meter the amount of particles they generate to pull them into the bulk or bring them out of the bulk, and they can target their exit and entry points and thus they don't need propulsion. They just need the ability to generate the particles. And I said this before, and I'll say it again. I think that's why these UFOs that people see are like this. They're actually round, okay? And the reason they're round is because, let me just do this for a moment. Okay, the reason they're round is because these are actually particle accelerators. There's an outer ring in here, and the occupants are in the middle. And with a ring like this, okay, you're going to get what's called synchrotron radiation radiating out in all directions. And if you're shielded on the interior, you'd be fine. It's just on the outside, you may not be. And there's encounter evidence that shows that people that have been close to the outside of a potential UFO, if you want to believe the story, are severely burned by radiation. Now, could that be synchrotron? Maybe, right? Because they only have to shield in one direction, and that's toward the core, right? And so this, this is approximately 30 feet in diameter, according to what people talk about. And if that's the case, then it means that this object, with its accelerator in here, is generating the particles that surround the ship, pull it into the bulk, meaning that as it does that, it's generating micro black holes. The micro black holes absorb the gravitons the Earth is emanating to hold us down to the planet, if you will. And thus the UFO, if it's a real object at all, right, these objects don't allow Earth gravity to reach them. They don't repel it. They eat it. They eat the gravitons they generate, suck in the Earth gravitons, so that the Earth gravity never reaches them. So that's why I think that these are described as sometimes fluttering like leaves in the sky with no real sense of up or down, because they don't need it. They don't need it. Only when they turn off the generation of these particles can they actually set down on the ground and open a way to come out of the craft and leave the craft if the accelerator is not running. So there's a lot of future technology possibly in this concept, and that's something that I'm very, very interested in. And the guy that created that is a good friend of mine, Bob Schroeder. We do have some Red Sea. We're getting a little bit of the sunset. I knew we would. Right? And Bob Schroeder is the guy that initiated the study of the potential mechanism by which they actually get here. Curtis, I started to watch your first talk. He asked me if I saw his talk, but I was interrupted incessantly, 1,000 times, and I didn't get to actually see it in full. It's just like I'm just not given the time. I tried to watch it several times. I went in even after midnight, and guess what? I get phone calls. And people got to know something right away. All right, well, that's the way it works sometimes. But I will do that. I want to see all your talks, actually. Curtis Horn's a very intelligent guy. You guys, if you get a chance, look him up and check him out. All right. Mr. Spiritus 001, how are you? Yeah, there's plenty of sound. Everybody hears me. We do have sound. So Marky tased yet, Do says. No, Marianne's not tasing me. And that ain't gonna happen. I don't even think she's here right now. If she's here, I haven't seen her. Dean Bustador is here. Petita is here as well. Petita, sweetheart. Hi, Petita. Nice to see that you're in the chat. Okay. All right, so we've got a number of shots here. Let's save these. I'm going to write the name in as Little Beehive. It looks like it's going to be a really nice, it's a real nice night out there. Okay. We'll save it. Really nice. And we'll save it exactly as seen. All right. And we'll get out of it because we're going to move on. Isn't the dolphin head near here?
If I remember correctly, yes.
Yeah, so we should check that out. But before we do that, let's look at something. that might be a little more interesting to folks. Let me get us to a little enlarged. Okay, now let's go back here. I like when we have lots of satellites. I hate to say that. All right, but let's back out. And now let's do one thing while we're here. Orion is going away, folks. So let's take a last look at the Alnitak and Orion Nebula region, shall we? Let's make sure we can get there. Okay. And let's do that. We should see Alnitak pulling in. There it is. There's the Flame Nebula. Really pretty. We're seeing it through haze on the horizon, but that's okay. Izabela says Orion is going away and summer is coming. Yeah, but not before the galaxies come. We're going to have galaxy season first. Calabos, thank you for dropping in for the amount of time you could. Good night. I want to talk to you about SpaceX. I've got some things I'd like to share with you. Okay, let's now move over a little more to the west here if we can. Here we go. Oh, Do is saying I'm muted on the computer because I'm on your TV. Okay. Yeah, Jupiter's going bye-bye too, Dean. At least for a little while.
Actually, it should be visible during totality.
Oh, yeah,
It'll still be east of the sun at that time.
Yeah.
But it is getting ready to pass behind the sun and return to the morning sky eventually.
And we'll make this a 20-second exposure. Wait, where'd you go? Wow. Do we have that much wind? That's crazy. Wow.
Telescope control says Starlock guide searching.
Yeah, I see that, but the wind blew it enough, apparently. So let's go and drag this back. What happened? Let's go drag this back. All right. I don't know why it did that. It went far away. I think maybe I have... I'll come back. I think maybe what happened... and actually, what we have to do is actually maybe bring this back up. I gotta let Starlink stabilize because it's not. In just a minute. Okay, now we're catching up. All right, let's go back here. Well, it's a good thing we're not doing this out at Mars. could take like 20 minutes at the most, and about 4 minutes for each command to get out there. Okay, so we're there. And we should be able to go do this now. Here we go. Alright, so we should be coming back. There it is again. I think what happened was that my slew rate, yeah, see, the slew rate was too high. I don't know why it went way up there, but that's what caused this. Alright. So now I can just drop us down and get back to where we want to go and take the picture. Michael Hedrick's asking, do you think gravitons could help us send messages through space-time? I don't see that as a communication methodology at this point, but it's possible that there's some loophole I have yet to understand. Maybe not, but I don't think so. Hey, Curtis, I would love to license a high-altitude balloon research, but every university under the sun is doing that. I was talking to someone the other day about getting grants for what we're doing, and he's pretty sure that since there's not really anyone doing this, that we probably, not the way we do it, right, that we probably have a way to really make this work. Okay, here we go. Let's go in here and do 25 seconds. All right. Okay, there we go. And I see that our progress bar, I gotta bring that back. There we go. Okay. So we're going to get rid of our, I may have to refocus. It looks like we're getting a little bloating, but we're going to find out here with this first shot.
Marianne is here.
Marianne is here. All right. Marianne, I told her we were going to stream. Hey, Marianne. And now let's get our first full width half maximum filtered image. It may not go because... Oh, good. Look at that. It did. All right, we're at 8.13. Good. Yeah, folks, show your love to Marianne. She's one of 3 people in SkyTour livestream that helps make it tick. 1 second here. I got a call from Bill. Bill, what's happening?
With Eric. Mark, what are you doing tomorrow, like 2 o'clock in the afternoon? You got anything going on tomorrow?
Tomorrow at 2 in the afternoon? I don't think so. I'm in the middle of a stream right now, so you're on the air with me.
There's Eric.
Eric, how are you? This is Eric
Good,
from...
how are you doing, brother?
Eric from KGRA. How you doing, man? And Bill, our esteemed producer. Nice to see you guys here.
Yes. Well,
I hear you. I don't hear them.
I'll hit you up on Skype.
Okay.
We're ready to start the Kings.
Alrighty.
So class will be in session at 2 p.m. tomorrow Eastern.
Alright, I will try to be there with bells on.
Okay, because also ready.
Yeah.
And for those that are on Mark's stream listening, hello to everybody there. This is to take the 107 certification course as a drone operator.
Right.
So the 3 of us are going to do it together. We're going to take the course together, we're going to study together, and it's going to be a lot of fun.
Yeah, and we're going to hate each other by the time we're done.
So, I didn't mean to interrupt your stream.
No, you're not. And that's not. You guys are always welcome to join me. I have Daryl with me here right now, and
What's up, Daryl?
see, he says, "What's up, Daryl?"
Hi, Bill.
He says hi. He can't hear you because I don't. He's not hearing it except through the stream, unfortunately.
All right, so have a great rest of your
Sometimes I hear him, sometimes I don't.
All right. So you said 2 o'clock.
Yes.
All right. Please remind me by incessantly calling me, okay?
You want me to? 'Cause you're collecting people.
I do. I want you to remind me so that we can start because it's a good thing to start.
Yeah, 'cause I can get very annoying.
All right. Yeah, I know you are.
All right, Mark, see you tomorrow.
All right, guys. Great hearing from you. Thank you. We'll see you. Bye-bye. See you, Eric. Okay, sorry, guys. That was Eric, owner KGRA, and Bill. And we're starting a class tomorrow on the Part 107 drone stuff. Bill's really excited. He got a new drone. Oh, boy. I have a fleet of them. I've never been Part 107 certified, so now this will get me certified. Look at the detail, Daryl. This is incredible. I just love how much detail we get in here. And I did it this way so we could pull this out up here. You see that? Yeah, you do.
Uh-huh.
Yeah.
I see a blue artifact right above the
No,
nebula.
that's right. That's the Alnatak artifact. Yeah. Papa Tom. Hey, Lubo in Chile. Lubo in China. How are you, man? Nice to see you. All right, and Du is heading on out. Thanks for coming. And Lubo says, in 1973, Pierre Lena, a French astronomer, took a chance and with modified Concorde airplane to follow the solar eclipse for 70 minutes. Is the video true? Why is it so difficult to find more info? I actually don't know the answer to that question, Lubo. That would seem to be a very good idea to do, chase the eclipse shadow to keep it in totality longer, and at the speed that the Concorde actually went, it was probably possible to do that a little bit anyway.
I remember hearing of that, I think.
Mm-hmm.
Been a long time.
Yeah.
I forget where that happened at, over Africa or someplace.
And wherever they chased it, I guess they would have to, huh?
Yeah.
This is beautiful. Look at that. And this is fairly low to the horizon right now, too. If you look up here, you can see the telescope is leaning way over. Yeah. Yeah. Wow. That's something. Yep. This will be just a flame nebula. And it's an emission nebula. Yeah. Now we have some shots that are being dropped. And I'm keeping the full width half maximum value at 8.62 right now. Anything bigger than that, diameter wise, effectively, we're going to ignore. That way it keeps our stars round. Otherwise, we'll have dashes for stars, and it'll ruin the shots. One bad image will ruin the shot. So this will not allow us to ruin the shot anymore. Hey, Rockstar, what's going on? Nice to see you here. Curtis says Lowell Observatory used to do interactive stargazing. Melamed, and then live stacking. Yeah, why they don't do it anymore is a mystery. Probably because it's too expensive time-wise. Probably too expensive time-wise. So I was saying before, last night I did a talk on solar eclipses, and this solar eclipse, to a full house in Danbury, Connecticut. A lot of people were there and had really, really good questions. And some of them will probably join the chat too, because they all got cards to join SkyTour live stream. And Lori Arbuthnot, how you doing, Lori? She says, I see a post you were showing the eclipse. Yeah, I was just talking about the class I taught yesterday on the eclipse. A lot of people were very motivated to see it. I don't think Calabos is still here, Marianne. He had to go to bed. He's a wimp. He's a wimp.
Yeah, he had to go to work at 2:30 in the morning.
He has to be up early, yeah. Yeah, kind of like the time that you dragged me out of my bed at your house. Remember, I was in my room and you came in and said, come on, get up. I go, what? It was 3 in the morning because I had to go on a ride along with her as a cop. She was a cop. I had to go in her car. And don't get me wrong, it was a great time, you know, but I didn't get the little vest that has the reflector on it, you know, and so I wouldn't get out of the car and get into traffic and direct traffic at an accident scene. So call me a wimp, but I just felt for my own safety it was probably best, especially in Phoenix where people drive like madmen. Such a liar story there. I am not lying. You did not have a vest for me. And that is not a lie. You know?
He didn't give you a gun either.
Well, that's okay. I do have one out there, though. And actually, I got it through her, actually. It was very nice. Hello there, Ronald. ERT Radio. If you haven't heard of Ronald's radio station, ERRT Radio, over on Mixler, I think you got a website now, Ronald, that I want you to put up. Put up the link to your website, too, so people know. Okay, we got 14 of these stacked over here. You can see right here. 15 with 5 rejections overall. We're getting a lot of good ones now. This is good. Yeah. Look at the subtlety of this nebula. Jesus, it's beautiful. Let's see if we can pull out a little more detail in here. We'll do it like this. Pull this in. Right? Look at that. Okay. Oh, I know what I gotta do. I have to add some enhancement. I'm gonna immediately get rid of some color noise like this. Bam! Look at that. And then I'm going to add an unsharp mask, which will sharpen up some details a little bit. Oh, look at that. Now it's really showing up well. Curtis says they have a 32-inch Dobsonian telescope there. A Dobsonian is basically the easiest way to get a large light bucket of a telescope. The cheapest way. However, 32-inch diameter telescope, if you did that with a telescope like this one, you'd be looking at probably several $100,000. A 32-inch Dob wouldn't be a tenth of that cost. It'd be a much smaller cost, actually. Okay, Michael Hedrick, I'll get to your question in a second. But a 32-inch Dob, I've used a 25-inch Dob, and it's really cool. And I did research on a 24-inch Cassegrain and a 20-inch Alvin Clark refractor. And that was really cool. The 20-inch Alvin Clark refractor, the building was so large that the entire floor was an elevator that would move up and down to meet the telescope. So you could conceivably be 2 stories above the ground if you're looking at something that was kind of near the horizon and the telescope was more horizontal than it was vertical. And you would be 2 stories above the floor. And you're doing this at night, in the dark, usually in the cold, because winter's still nights were ideal. And we would end up really getting paranoid about working near the edge of that elevator. Yes, there was a railing, but it was just a railing. If you slipped and fell, you'd go over the edge and fall 2 stories to your death in the concrete pit below. So nowadays, that isn't like that anymore. Rocket City Astros with us. Hey, man, how's it going?
I got to look through a 41-inch Dobsonian once.
I bet you see color in that one if you looked at the Orion Nebula.
It was summertime actually, and I
Lagoon
got to
look.
look at Messier 51 Whirlpool,
Oh yeah,
and yes, I saw color. Looked
yeah,
like a looked like an image, looked like a
yeah.
photograph.
Color is all about light gathering power. You know, if you have more light gathering power, then the cones in your eyes can be stimulated enough to actually respond with a color response. And the rods are the black and white receptors that ring the retina, and the cones are in the middle. So usually when you look at something faint, you look to one side because then the side rods in your eye pick up more detail. They're far more sensitive. And so with the side vision, you can actually see more detail in your peripheral vision. And when you look at it, you don't see it anymore because it's too dim to set off the cones. So I think that that's probably something that, you know, turns some people off. You know, when they first look in the telescope, they expect to see that. Okay, they expect to see it just like this, you know. And as beautiful as that is, I mean, look at all this intricacy in here. This is stunning. Look at all these beautiful lines here and these gorgeous dark features. That's really pretty stuff. And people want to see that when they look in the telescope. But you really need a massive instrument to see something like that. And so, in all likelihood, you won't see that except in one of these types of telescopes where we're doing an ongoing image, a live stack, as this is called. We are stacking, as you notice. We're up to 21 images right there. Okay, that means we take one image, take a second image, align it with the first, star for star, and then just keep stacking images and stack them and stack them. That eliminates the noise in between and within the nebulae and allows subtle features to come out. So right now, if we zoom in, this is going to be a really a pretty zoom. You can see all this detail in here. Look at this detail. Look at that. That's pretty amazing.
Lubo has a question. You could probably answer better than I could.
All right, Lubo says, would not so narrow band filter in front of the corrector plate sort out the bright star reflection problem? And what is the cost of an 8-inch filter? Well, this is a 10-inch system. So I don't want to, I wouldn't want to rob the light coming into the telescope, coming in. But somewhere in the optical train, if you put a filter, you are robbing light, but you might be also removing extraneous light. I get your point. But you don't, if you put it in the optical train somewhere along the way, a 2-inch filter can work on a 10-inch telescope without any problems. So that's what we do. But I have a narrowband filter, and I've used it, and I've shown it to folks in SkyTour. They've seen it. But with this telescope, one of the problems we have is that the telescope, and at the front end here of the telescope, right? It looks like, see, look over here. This is the front end of the telescope, right? Right? And in that front end, the camera, this is a dew shield. And this is the telescope proper. But right up here, there's another lens in here. And then the camera is right up in here in the front of the telescope. And it's up there in the front of the telescope because that actually helps us change our focal length of our telescope. In other words, how fast it is photographically. So you can capture things like this in only 20 seconds, which might normally take 20 minutes to capture. And so that is the advantage of doing it the way we're doing it. So that's what's going on. And of course, this is Alnitak, the leftmost star in Orion's belt, and this is the beautiful Flame Nebula. Daryl, I'm going to tell you right now, in all the past, do you ever remember us being able to see more than just this? When we look at the flame, normally we saw maybe a little bit of this, but we never saw all this detail out here before, have we?
No, I think it's been there. I don't remember ever seeing that blue reflection or whatever it is before.
Well, that's just a internal lens reflection.
I understand, but I don't remember ever seeing that before.
Well, that might be a definite addition to the light train, just like these halos have been. Hey, Fern Trev, how are you? This is the Flame Nebula, Fern. It's just to the left of the leftmost star in Orion's belt, Alnitak. And if we go look at our planetarium image, I'll try to bring that up now. Let's see here. It's we have Starlink, so sometimes it takes a minute. The leftmost star in Orion's belt right there was Alnitak, and that's this one right here. I know it didn't really stay there for long. Let's bring it back up. Okay, there it is right there. And right below it is the Horsehead Nebula, which is where we're going to go next. And then from there, we'll move our way into some galaxies as they are becoming more prominent and southerly to our telescope view. Betelgeuse is actually on the way down. And I'm going to try to show you this. This is our all-sky camera. All right. The all-sky camera here, these are the stars right now live. Here's Orion right there with its belt. There's a satellite going through Orion right now. There's Betelgeuse. There is Alnitak right there, right? Alnilam and Mintaka. And this right here, this is Gemini, right? And this is, well, how would you know? Well, here's how you know, because over on the left, if you click this button right here, and you'll get a chance to do this, you see the constellations. And you see what we're looking at, and you see the objects. If you hover over a Messier number, like Messier 81 and 82, okay, you'll see their picture come up. And if you click on them, it'll bring you to the website and show you all kinds of cool stuff about it. You can see Jupiter right down there on the horizon. Orion is getting close. So these give you an idea where we're looking. Here is the Leo the line right here, the reverse question mark, and then the triangle back here. And of course, this helps you see that better. There's the triangle, and there is the reverse question mark and Regulus. Okay, so this is the new camera that I installed when I was out there a couple weeks ago. All right, and this also makes a time lapse. So what you get is time lapses of every single night. You'll be able to click on these and see, even on rainy days, you'll get to see what's going on and do a time lapse. We also do an amazing set of star trails, so you can see the star trails for one night. And what it does is it also shows you all of the meteors and satellites that may come in. This was actually the ISS that was here briefly at that point. But as you can see, there's lots of stars here in this particular location. So we got a lot going for us at this site. So it's pretty cool, right? And so that is our all-sky, right? And that's a bird turd on our thing. Already, yeah. I actually went out there and I actually, this is hermetically sealed, this container, and that it's in, and I actually put it in, I added a nitrogen gas as a cover gas inside to actually keep us from having to worry about the moisture in there. So the nitrogen displaces the water. I just sprayed nitrogen gas in there and then sealed the box up, and it's airtight. And I don't want it to be exposed to the outside air, because if we do get rain, that moisture will get trapped inside the box, and I don't want that. So I do have a fan on the system. It's internal. At night it cools off. During the day it gets hot, and I monitor that. Look at this detail. Wow. Okay. I would say that we have created just enough. We have one more coming in, and we're going to make 30 if we can get to it. We only got one here. Let's see if this next one comes in. Once we get to 30, we're going to save it. Well, there we go. Okay, so we have the Flame Nebula, and we're going to save it. And then after we save it, we're going to save it exactly as seen. You'll see the green bar across the top saying we've saved it. Save it exactly as seen. And so what you get, if you let me click on it, you'll see it. This is what you get. And this image is available from skytourlive.org right here. You can go there, scroll down, it'll tell you how to get access to our server, where you can then download this exact image and then have fun with it. Do whatever you like with it. Okay, so now that we did that, we're going to jump out of this and we're going to take ourselves to the next object, which will be just below this. And I want to make sure that we can image this object. It is actually okay. We got back to that. The telescope sometimes goes into a slew mode, which I don't want it to do. So I'm not sure why it does that. Let me oh no, it says 16. All right.
Well, I don't see tonight's images on the server yet.
Okay.
When it shows up, I'll post a link.
Okay. Michael Hedrick says that Lubo had a Hubble question. Did I miss it? Oh, another question. I have 2 months worth of Hubble variable nebula data and want to make time lapse with constant brightness using stack file. Oh, which software to use? Well, I would probably not stack them, because if you stack them all together, then you mix all the brightness variations together into one file. You probably want to keep them separate, and maybe on a single night, if you stack like 10, 20 images from a single night, and then from another night stack 10 to 20 of those images and just keep doing that, that's probably the best thing to do. Don't stack them all, because then any brightness variation over the course of several weeks will be lost. It'll all be combined into one chunk. Thank you, Izabela, for putting that out there.
What he might try, instead of stacking them, is making a little mini movie, like a GIF or something, a GIF.
Yeah, but for each night, if he takes 20 images of the variable nebula that night, he can stack those to get rid of the noise. Okay, but then don't do anything else to that. Keep that as one frame of the GIF file you're going to then make. Then the next one, stack another night's worth.
He says he has.
Okay, good. Well, that's a good thing to do, Lubo. That's a really good thing to do. Hey, Fantasy. Fantasy's with us. Look at this. It's almost like rain. Like tears in the rain.
Interesting. There is no file for tonight on the server.
No?
Nope. Still hasn't shown up.
Okay. Oh, let me see. Let me try and see if the reason for that is my fault. Let me try this. Okay. It may now. Okay, let me just bring this up a little bit. A little satellite right there. You know what that is? That's a geostationary satellite. I think. This is only oh, I'm so sorry. This was a 25-second shot. I don't want that. No wonder it's doing crazy things. Yeah, that's what I thought. Okay, my mistake, guys. I should have gotten out of that, because here's our horse head. I need to bring us back down a little bit. There we go. I'll put it right here. And that's good, because we got a beautiful reflection nebula here and a beautiful reflection nebula here, and the horse head right there. All right. Now what we'll do is a 25-second shot in here. There we are. Let's get in there. Here we go. All right, 25 seconds. Okay, waiting. Still waiting. All right, I'm going to kill it and come back in, because sometimes I have to. Sorry about blowing out your eyes if you're looking at this on the big screen.
Mark, while you're resetting everything, will you excuse me a moment, please?
Sure.
Be right back.
Sure, it'll be right here. Okay, so now we're here, and I'm going to come out of there. There's another Starlink satellite. And we'll pop out here. Go into a live stack. Clear this live stack. Set this up to be the Horsehead Nebula. That's a DN, or a dark nebula, so I'll put DN after it. And we'll get our first one now. See how we go. And maybe our filter. Okay, we're waiting. It's so nice to be back to doing this. I like having good weather. Okay, I'm waiting for image to show up. It's rejected 3 images so far. Let's try raising this value just to make sure. Okay, so we got 1. Why don't we see it? All right, let's get rid of this. Okay, and now we got that. Move this up a little bit. All right, that's good. And color correct. Too far. Go away. And do this. Now you see the noise in here? This is the stuff that stacking gets rid of. That's why we do this. That's why we stack on top. Izabela, thank you so much for putting that out there. Please put the address for the server. Curtis Horn says when you do a stack, you have to adjust the histogram It's true. I'm always adjusting as it gets done, because some of the data that it brings in is extraneous data that you don't want. Here I am darkening up the dark side of this, the dark level, because I want to show some more of the detail in here. And I might take the mid-level, and move it over at some point. Right now I'm just doing this. Yeah, see, we're only going like 50-50 here. Yeah, see, 4 rejected, 4 accepted. Thank you,
Mark?
Fern.
Can you share screens again, please?
Oh. How did that disappear?
I don't know.
What did you do? Okay, let me do that. All right, here we go. Here we are. Okay. As you can see,
Thank you.
this area here is part of a vast complex up there in Orion. In fact, if we took a drive out there, you'll see this dark area all in here. This is like a wall. This is all in here. This is all, and it extends far beyond the size of this image. This is just a piece sticking out. It's actually dark nebula and dark molecular. There's dark molecules out here, molecules of carbon, molecules of silicon, okay? And they're out here, and they attract other compounds to their surfaces that form ices. Like you have formaldehyde, you have methane ices, ammonia ices, carbon dioxide ice, water ice. And it forms a shell over the dust grains that are these black dust grains. And when there's a star like this one right here, okay, this star, for instance, okay, this star is actually shooting off a ton of light, right? Obviously. Well, some of that light is being absorbed and then immediately scattered back to the cloud all around it. And that light that it likes to scatter like that is blue, the blue part of the spectrum. And that's why we see blue nebulas, because it's only the blue component, only the blue part of the spectrum that's actually being scattered back, right? The red light, the yellow light, the orange, the green part of the spectrum, all of that is being allowed to kind of pass through. But this blue stuff, the blue light is scattered. And this is blue for the same reason our sky is blue, because our molecules are doing the same thing in our atmosphere. So when you see a blue nebula in space, know that it's there for a very similar reason to why there's a blue sky on Earth. All right? Scattering, and the blue light is a higher frequency, right? Short wavelengths is higher frequency. And so the blue light frequency is very easy to scatter by small particles like we see in here. And that's how that works. And so let's pull myself back and get out of your way, because I was in your way. So that's how that works, you know. Now what I could do here is just drop that out of the way, and then move the telescope out of the way for a minute, because we can just do a full screen view here. All right, and there we go. So this is the full screen view. Remember, all of these images are available at skytourlive.org. You're free to take them. We provide them for free. And if you want the highly processed ones, if you want to see absolute stunning masterpieces, you can join our Patreon and get them each month, under that subscription for the Patreon. But so check out our Patreon as well, because that's something that is kind of unique to what we do, and there's not a whole lot of people that there's very few people doing what we do. I haven't found anyone that really does what we do online. People stream stuff. They stream taking pictures, but that's usually not an astronomer. I'm an astronomer. That's what I got a degree in, and I'm taking the universe to you. So we say it's the universe live in real time. We have new T-shirts, by the way. If you want a SkyTour live stream T-shirt, let us know through SkyTourLive.org, and we'll tell you how you can purchase one of those. I think they're $25, but it says SkyTourLive.org on the front, and on the back it says Universe Live in Real Time with a nice little design, and that could help us immeasurably in moving forward with everything we're trying to do. So we'd love to hear from you that way. So again, SkyTourLive.org. And if you're of a mind to actually see a little bit more about what we do, you can actually visit our Etsy store. Up there in the upper right, Etsy store, SkyTour Shop on Etsy. And many of the pictures you see here that we take, well, they're on bedspreads, they're on shoes, they're on bathing suits, they're on boxer shorts, they're on mouse pads, they're on mugs and glasses, coasters. It's just, we have all this stuff that we've done. And because we're a 501c3 nonprofit organization, and we're trying our best to create a new experience in astronomy for people, and this is how we're doing it. Marianne, Tara, and myself started this several years ago. It started on the front lawn of my house here in Terryville, and that was before Marianne and Tara were even involved. I started it myself with, I had a different co-host, and now I have Daryl, which is great. Daryl, I call the astronomer's astronomer. He knows an awful lot about what's going on in the sky, and then I can tell you what those things are in the sky and a little bit more of the details about them. And he's someone that actually knows the sky like the back of his hand, which is really cool. For instance, thanks to him, I know that this is his favorite star. One of them, Sigma Orionis.
Sigma Orionis is what's illuminating the Horsehead and the whole cloud bank around it. Sigma Orionis is a beautiful multiple star system. It'll take your breath away in the telescope.
See what I mean? This is what you have waiting for you at SkyTour Livestream. And this red cloud here, this is hydrogen gas that's being ionized by the hot ultraviolet light coming from this multiple star system. And as such, the hydrogen atoms that were in here, their electrons are excited, they bounce off the atom, and they absorb energy as they do that. And then when they bounce back into the atom, when they fall back into the atom, they give off energy in the form of this soft red glow. And so that's what we see when we see ionized hydrogen. This is the result of the ionization end process, where the electrons are rejoining the atom. Okay, and in this case, as Daryl just pointed out, this black nebula here, this dark cloud of molecular components of carbon and silicon and other ices and so forth, is silhouetted by the glow behind it. It's really cool. And if you look carefully, you'll notice that the top of the Horsehead also has a soft illumination on it. And this is not a blue nebula. It's actually just dust that's illuminated by the star and not quite scattered. It's just a reflected light coming back from all that dust. And by the way, this is long. This is light years long here, a couple light years in size. Knowing how far away this is, I can measure this on a film plate that we make here and tell you exactly how big it is. And that's if it's flat. It tells you the smallest size it can be. If it's at an angle, it means that more of it's coming towards you, and if you were to turn it sideways, it would be bigger. So we can get the smallest size of something by doing that.
Mark,
Mr. Django's with us. Yeah, go ahead.
Server's still not working.
All right. Well, the images aren't lost. Images aren't lost.
Fern Trev, it's not a moon. It's he's asking about a nova. It's a star called T Corona Borealis.
Oh yeah.
They're expecting to go nova sometime soon. Now, that's not a supernova, it's a nova. It won't be as bright as a supernova, and hopefully you can at least see it naked eye. If not, hopefully you'll be able to see it in a binoculars or a telescope. But
Yeah.
it's a star that's going to undergo a case of rapid brightening, and then it'll
We'll be able
fade
to
out
see it.
again.
We should be able to see it. It's up.
Yes.
It's up in our view right now.
Yeah. Corona Borealis is sort of the third point of the triangle with Virgo and Leo, where a whole bunch of galaxies are, and it's just to the east of the tail of Leo,
Mm-hmm.
and it's one of the stars in the constellation. Corona Borealis means northern crown.
Okay. All right. Let's try. All right. Let's try this. Okay. If this
Speaking of
works.
novas and supernovas, APOD had a really cool image up last night. I don't
Okay.
think I shared with you all in the group chat. They think it's a supernova remnant with a so-called zombie star
Zombie
inside.
star? Wow.
And I had to read up on zombie stars. I don't think I'd ever heard the term before.
Yeah, we talked
They-
about it in the SkyTour radio.
Oh, did you?
We did, yeah.
They said it's a kind of a special sort of a supernova that happens. It's not a type 1A, it's a type 1AX, I think they called it. And they think it's when two white dwarfs merge that they gain enough mass when the two white dwarfs come together to create a supernova, but generally one of the stars survives.
Yeah.
And then it's called a zombie star. If you go look at Astrophoto of the Day, APOD, I'll post a link here in a minute. It's a really cool image. And you can see the zombie star glowing blue in the center.
Mm-hmm.
Let me go find that and I'll post it.
Okay, I figured out obviously that. Well, we're waiting anyway. We're getting some more shots here. We have 20 stacked. Okay, I'm trying to.
There's the link to it's yesterday's APOD now.
Okay.
Fascinating picture though, and very blue object right in the center is a zombie star.
Okay. All right, I'm trying to. All right, I'm trying to actually just sign us in here so we can start the synchronization process. That's not it. I want my email.
Well, I hope I didn't screw you up.
Oh, you didn't screw me up. I'm trying to actually just do the
You
sign in.
Screwed it up all by yourself.
I did. Yes. And save. Yes. And let's go see if that was the right address. All right. It looks like it is. So if I come in here, this is our directories. Let's make sure there's data in here. 24 minutes ago, little beehive.
Yeah, it's up now.
Yeah, it's starting. Okay. I just had to get the server logged into, guys. That's why. All right.
I will
Thank you
post
for
the
your
link momentarily.
attention. Thank you for your support. All right, so here now you see the horse head. Since we last visited it, it's looking better. You can start to see more detail in it right here. That's pretty cool. I have a gigantic curved screen in front of me, guys. So if I'm looking here, I'm looking at the observatory feed here. I'm looking at the broadcast feed here. So I see all the details of the broadcast here, and I see all the details of the observatory feed here. So that's why you see me doing it like this. Okay, so let's go in here. We have lost a few, but we got 21. That's pretty good. And let's bring the telescope back here a little now. Just pull that back. You know, and we'll do that right here. So bring the telescope back. Yeah. It's kind of fun to think about the fact that that telescope is 2,500 miles away from me right now. It's also scary to think that such equipment is literally so far out of reach if something goes wrong. I really understand how JPL feels when they place a rover on Mars and they send a signal to it and they don't hear from it. And they're like, You know, that's kind of what I'm doing. It's sort of like a similar kind of thing. Okay, Horsehead, we're going to save this. And we'll save it exactly as seen. Alright. And we'll jump out of that. Go back to our expanded view here with our kind of our night view. Okay. And let's go down to, say, 25%. So here's the full frame that we're looking at. And then we go over to our... So this guy... And you can see now, look how far Orion is laying over on the horizon. Look at that. It's so close to the horizon now. So we're going to come back up now. And I was talking about the dolphin head, but I think I'm going to skip that. We can catch it again tomorrow night, maybe one more time. Wow, there's a bright satellite. Went right through. And let's go. We have the full beehive up there. Now, is it T Corona Borealis?
Yes.
Yeah, okay. Let's try looking at some galaxies here in Leo. All right. We'll do M95, M96 right here. And we'll just tell it to go to that spot in the sky. And you'll watch the telescope swing around. There it goes. It's moving around. We're going to get streaky. We're going to get all streaky. All right. And then it'll come roaring into here. You'll see our crosshair show up in here. There it comes. And when we cross that much sky, we have to adjust and make sure that we're where we think we are. There was one of the galaxies there. So what I'll do is I will move us up. And see if that looks like that brings us to where we want. So we weren't that far off. And I will see if we need to refocus. I'll zoom in and see if we have to refocus.
Scoot up a little bit. I think you can get M105 in the same view also.
Yeah. If I go up, even if I go down, bring the image down. Because that's up here, correct?
Yeah.
Yeah. I just want to try and get It might be. This is M95, 96. Well, we'll do it. I don't want to go too far. I want to actually be able to capture these with all the good pixels here and no distortions of any kind. So we're pretty good. So I'll just go to here and I'll actually drop down a little bit, make this M95, M96 only. Then once we drop down, we're going to end up starting up our guiding system, which is starting right now. If you look here, when you go here, it's searching. It's finding stars. And when it finds stars, it takes about 12 to 14 seconds. It starts guiding. There it goes. You see it starts with all zeros. And then it begins guiding. And so now we can set up the shot. We can say, okay, this is going to be 25 seconds, which is 25,000 milliseconds. Yep. And now what we're going to do is come in here and drop out this histogram, which is brightening everything artificially, and capture in a live stack what we're looking at. This is the old one. This is the clear. We're going to clear this out. It's up there being uploaded now.
Michael H., you would get X-ray vision the instant the wavefront of the neutrinos hit, and you could do naughty things.
Look at that.
Sorry, I kid. Michael
What was
asked,
his question?
What we might see if Betelgeuse was supernova during the solar eclipse. It'd start getting bright.
Yeah, it would
Beyond
actually.
that, I couldn't say. And
You would suddenly see a star in the sky that you didn't see before.
well, during the solar eclipse, I dare say Betelgeuse would be visible.
Oh, I agree with that. It'd be visible even as Betelgeuse without going supernova. And if you're in totality.
Well, that's what he's asking. What if it went supernova during totality?
Well, even if it wasn't a supernova, we'd see it in the daytime sky anyway. It's going to be that bright. Just like the Chinese saw it in the Crab Nebula progenitor
Yeah.
in 1054. Yeah, that's pretty cool, huh?
I mean, it would take a while for the thing to achieve max brightness, though, wouldn't it?
Oh, yeah. I'm sure. Nice thing, though, is that, we have a warning if a star is going to go supernova. That warning comes in the form of neutrinos that actually Daryl mentioned earlier. Because, in fact, I dare say that if you look at the physics of a supernova, the neutrinos are actually in part responsible for the supernova, even though they're also a result of a supernova. Because once the core collapses inside a star, because all the fusion stops, it can no longer support the overlying mass that's trying to crush it with its gravity, so it collapses inward, and the neutrinos are created and they stream out. And 1 in 1 billion neutrinos actually escapes the star. But still, we get many, many millions of neutrinos that leave that supernova star, even though it's only 1 in a billion. So that's how many neutrinos are generated. And when those neutrinos leave, they leave at the speed of light. And the ones that leave without getting stuck and bouncing off and absorbed by other things along the way, those that get out are on their way to us. If they're facing, the ones that come out toward us. And the ones that start on the journey will get here at a certain point. Meanwhile, inside the star, all right, back at the star, the neutrino leaves at the speed of light. But the inside of the star, a supernova, is a physical matter thing. The matter has now started to collapse into the center and bounce off that inert core of iron and nickel. And so it bounces back out. That rebound is physical material now coming out. And it comes out in a shock wave that rips the star apart. And the star from the outside looks perfectly normal for many, many hours and hours and hours after it's already dead. All right, and that shockwave starts moving toward the surface little by little, and eventually when it reaches the surface, boom, it explodes out of the surface, disrupting, as we call it, the star, destroying the star, and now we see the visible signs of the supernova. But if we see neutrinos, we know where to point our telescopes. Hey, something's coming from Betelgeuse. Betelgeuse is going supernova. Well, I don't see anything. I just see the red Betelgeuse. I know. The light train with the neutrinos has reached us, and right behind it is the light train of the explosive shockwave reaching the surface of Betelgeuse and beyond. So it seems slow motion, but it's really an astonishing thing to see. I can't wait to see it. And Ronald asked, did I change my schedule to watch the eclipse on Monday? Yes, I'll be able to see the eclipse on Monday. And unfortunately, the camera that I need to stream it, I don't have. And I was looking for a unit I have to attach another camera to it, and I cannot find it. It's here in this shop somewhere, and I can't find it. So I won't be able to stream the eclipse. I want to. But there'll be enough people doing the eclipse stream for sure. High Point Scientific is going to do it for sure, and a lot of other people will do it. You know, I do have a Coronado Systems sun telescope, solar telescope, and I'm going to be using that to create our solar observatory, at least to begin with. And we're going to put an additional lens system on it for additional detailing, and then we're going to trade up and get a far better system from a company called Lunt, L-U-N-T. It's going to be really cool.
You said earlier you're at 92%
Yes,
coverage where you are in Connecticut.
that is
Boy,
correct.
if I was that close, I'd try to get to totality. Except it's going to be an absolute zoo up there.
And that's the reason I'm not going. They're expecting over
I
1
hear
million people in Stowe, Vermont
Yeah.
to descend on that town. And the hotels were sold out years in advance
Yep.
for this day.
Same in Texas, millions of people. They're predicting disaster areas and all sorts of stuff.
I know.
A million people at Niagara Falls.
Well, you're going to see all kinds of shots of Niagara Falls with the eclipse going on. That's going to be really cool to see.
Yeah. I've
Izabela,
been
maybe I
thinking
will.
about going, but that's too far for me to drive. And looking at the map of the path of the eclipse, if I made a beeline for a totality, it would put me smack in Dallas, Texas. And that is going to be such an absolute zoo down there, everywhere in Texas, but especially
Yeah, it
again
will.
around Dallas.
It will. This is an eclipse for the people that live on the line of totality. It really is.
Yeah.
People that can go out in their backyard, and you're going to see people, park your car here for the eclipse for just $10, or for $25 or $50, and people will pay it.
There will be a ton of people trying to make a buck off other people during that event.
Yeah, that's right. Lewis is here with us. Lewis, hey, what's up?
My sister near Kansas City, she and her husband are planning to drive down to near the Texas-Oklahoma, Arkansas border where the path of totality comes across into Arkansas.
Wow.
She missed the 2017 eclipse. I got to see it. She was up in northeast Kansas where the path of totality was going to run in 2017, headed towards St. Joseph, Missouri. They're on the Kansas side of the border, and they got clouded out completely there.
Yeah, there's some talk that there's going to be some cloudiness across the nation. I'm going to be in Arkansas next weekend, So not Monday, but the following weekend, right after it, I'm going to be in Arkansas doing a conference there. And I asked if they wanted a SkyTour live stream, but it's actually it's in Eureka Springs. It's kind of out in the middle of nowhere in a sense, and they don't really have good internet there. So I do remember it was hard enough to make a phone call. So it's going to be kind of crazy there. But there'll be people there looking at the eclipse for sure.
Well, I hope everybody gets to see it, but weather will inevitably get in the way.
Well, even if it's raining, if you're in an area where you're going to have almost 100% coverage, it's still going to get dark, and it's going to look like dusk to you at 90% and above. Until the last few percent of the sun goes, you just think it's a cloudy day. It doesn't get that dark until totality. And even in totality, it's not pitch black.
Oh, no.
You can still see, because you got a bright corona of the sun. The outer atmosphere of that sun is going to be really, really, bright. So that's going to be the dominant thing. It's not as bright as the sun's disk, but it's bright enough. You still want to use your glasses to view it, and heaven forbid, don't point your binoculars at it.
Yeah.
Only use proper protection to use it to look at the sun.
There is so much misinformation going around. I was answering eclipse questions as Abel on Reddit, and so many dumbass people were giving incorrect information. And
I know.
I mean, if you are in the zone of totality, during and only during totality, it is safe to remove your eclipse glasses or viewers, whatever. And that's the whole point of looking at totality, is being able to look at it without filters. That's where you see the corona and the little pink tongues of flame curling over the edge of the moon and the sun, all the really cool stuff. You have to do it naked eye or binoculars or with a telescope, but only during totality.
Yeah, I still won't recommend binoculars. And a reason, because people will just continue to look, and then when that first blaze of the sun comes back over a lunar mountain or something, that extra magnification could put a spot on their retina.
Yeah.
So only use your eclipse glasses, and naked eye only at totality. And you know when to look away, because you can't look at the sun now. You go, oh. But when the sun is just coming back, you might not get the warnings from your body that says, hey, you're damaging your retina.
Believe me, I had a timer running. People called out second contact, safe to take your glasses off, and they called out third contact, glasses back on. And when I was looking through binoculars, okay, to get a better view of the eclipse and what was happening on the sun and the moon itself. I could tell when Bailey's beads were about to appear before they happened, and I put down binoculars before the end of totality.
Yeah, and
I had ample warning that it was almost over, and I put down the binoculars. Yeah,
well, just don't listen to Daryl on this one, guys. Trust me, no binoculars looking at the eclipse, ever.
Well,
that's never a good idea.
I've been doing this for 43 plus years now, and I know what I'm about.
You have enough experience, but we're not going to try and tell people to look at the binoculars. I'm not doing it, and we're not going to say it. I'm not. Okay, and I'm running the show when it comes to this, and we're not looking at the sun with binoculars ever. It's a crazy thing to offer. Yes, you can do it. You've had experience doing it, but all the people that are listening now or later, I'm not going to give them false information. I mean, it's not false. It's good information if you know what you're doing.
If you know what you're doing. Well, one of the saddest things I ever saw here a few years ago, there was a partial eclipse going on late one afternoon,
Yeah.
and I invited the neighbors to come over and look at it through the telescope with the safe solar filter on the telescope.
Yeah.
And it was really cool, and there were some big sunspot groups, and it just
Neat.
looked really neat. But we were using a safe solar filter on the telescope. They brought
Yeah.
their two daughters over with them, and I have to guess it was at the teacher's behest that liability concerns, or whatever you want to call it. I've heard many cases of teachers telling their students never look at the sun, never, even during totality, just because they didn't know any better or they were doing it for liability's sake. And those poor kids, they missed a neat event because they would not take a totally safe look at the sun through a telescope with a safe solar filter.
Okay. See, with the solar filter, there's no reason you have to worry as long as it's a proper solar filter. You're absolutely right.
Right.
I
The
used to
teachers don't
do.
understand that.
No, that's true, and but that's, as if I always say, you err on the side of conservatism when it comes to this, and I pointed it out with a 12-inch Cassegrain system that I was using at a place where I was actually doing astronomy classes, and we were actually doing solar projection with this 12-inch system. And when I took out the eyepiece that was projecting onto the cardboard, and I just did the prime focus, you saw this bright disk of the sun coming through the opening at the base of the telescope. It was an open Cassegrain. It didn't have any corrector plate. And I was showing people, here is why you don't look at the sun with a telescope or with binoculars. And I passed a pencil through the back, okay? And the pencil was incinerated. And it happened instantly. As soon as it went through, it went boo and caught fire. All the paint was burned away, and the pencil was now charred in the center. All right, that's how quick it happened. And it takes your body a tenth of a second to react to pain. And it was milliseconds that it took to burn off the paint and start charring this pencil. So your retina would be destroyed, and much of the optic nerve behind it, just by an instantaneous view.
Oh, yeah.
And that's why I will never recommend and never even allow any recommendation to look at the sun with any kind of magnification whatsoever. Because, unless you're doing it safely under the auspices of trained individuals, okay, like Daryl or me, okay, or other astronomers or so forth, never ever even consider it. It's really, if you want to go blind, that's what you do. Because you'll have blindness, or at the very, very minimum, spots in your vision that you will never be able to get rid of. I know people that have been driven mad by the spots in their vision by looking at the sun.
Yeah.
Okay,
Michael
we're
H., let me try to answer his question.
Sure. Read it first.
You're
so we
asking
know.
about, let's see, Essex County, New York declares a state of emergency ahead of the solar eclipse. Why? And then he says, have you ever heard that before, Daryl? To my above why? Well, yeah, just recently. There's a lot of, there's going to be a lot of people showing up at popular places along the path of totality. And
Yeah,
they're
they won't have
afraid it's going to
facilities.
overload the infrastructure and the resources.
Yeah.
And
And
there's
it
not
will.
going to be enough gasoline. There's not going to be enough food.
That's
It's
right.
going to be, like Bill Murray said in Ghostbusters, cannibalism, cats and dogs living together,
Right.
It's going to be
I remember
absolutely
that.
crazy. Some places during totality. And some places are really freaking out about it, and they're declaring disaster areas.
Yeah, and that's understandable, but I think that it's also a reaction to the crazy nature of the world now.
Yeah. Who knows? Maybe cats and dogs maybe will start living together.
That's right. Cats and dogs living together? Yeah.
Well, and it's along the same lines why I said I would not want to be anywhere near Dallas, Texas during the eclipse because there's just too many people, and it's going to be an absolute madhouse. When I saw the 2017 eclipse, I started out, I live in Colorado Springs, Colorado, okay? I headed out before 4 o'clock that morning going north on Interstate 25, which was a straight shot all the way up to a place called Glendale, Wyoming, which was dead on the center line of totality in the 2017 eclipse. State park there, pretty place. There's a lake, a lot of campsites. I took off before 4 in the morning. It was smooth sailing until I got about halfway between Denver and Fort Collins, Colorado, and the traffic got really heavy. And then it came to stop and go traffic. And when I crossed the state line into Wyoming, right at Cheyenne, traffic came to a dead stop. Nothing was moving. This was 6 in the morning, and the eclipse wasn't until about 11 o'clock. Luckily, I had scouted a backup site, and I happened to come to a dead stop right at the Interstate 80 turnoff going east and west. So I took the interstate, headed east, and I wound up going to Scottsbluff, Nebraska instead. Wow. And it got busy as heck, but the traffic kept moving. And I got to town. I wound up some miles north of town, close to, if not on the center line. And there were a ton of people out there in the middle of nowhere, just a huge crowd, but not as bad as Wyoming was. Everybody packed up and left as soon as totality ended. They didn't even wait for the second half of the eclipse to happen. Everybody loaded up their vehicles and took off. And it was a madhouse, but traffic kept moving through Scottsbluff and back down past the Colorado border. And
then everybody was trying to get out of there, and then you were in traffic for another huge number of hours.
It wasn't that bad or that long. It got a little ways into northeastern Colorado, and there was a road headed west, and much of the traffic turned off at that road. They were headed evidently toward Fort Collins, Colorado, and it thinned out a lot. By the time actually the highway was on Highway 71, I took it most of the way home, and it was a much easier drive than dealing with the mess on the interstate. And I found out later that the whole state of Wyoming, all of it from the north-south interstate on I-25, much of the state was locked up solid for many hours. There was no movement. And there were a lot of horror stories going on about, people didn't make it to totality.
Cannibalism, and cats and dogs living together?
Yep, pretty much. But hey, it was the neatest thing I've ever seen in my life. Again, I've been doing this for over 40 years now, and it had to be the number one thing I've ever seen. It was just an amazing experience.
Yeah, I mean, I would also second it if you're near totality or near a place where you can get to it. I've seen one total solar eclipse before, and it's incredible. Yesterday I talked about the eclipse bands as well that can be seen and what it can do to people. Some people get nauseous from them. Some people get lightheaded and because they're not sure exactly what they're seeing.
Yeah. There's so much going on.
Galaxy. Yeah.
And in 2017, totality at my location was only about 2.5 minutes. Okay. And this time at prime location,
4.5.
It's like 4.5.
Yeah.
So 2.5 minutes to take in everything was really hard to do. And everything, it was dynamic. It was moving constantly. The sky wasn't just black or dark gray. There were reds and purples and blues shot through the sky, and You could see the corona around the moon and like
Yeah.
a big ghostly halo, and it was really trick looking. And could see the pink tongues of flame coming up over the edge of the moon from prominences on the sun's
Prominences,
limb.
yeah.
It
Yeah.
was really a trip.
So while Daryl was talking, I moved us to the Leo triplet, which is a group of 3 galaxies near the back end of Leo the Lion, just below the triangle of the rear stars on Leo. And you'll see them now if our image comes in. And it is. And there it is, the Hamburger Galaxy. And these galaxies show beautifully. Look at the detail in here. And as we move forward in our stack here, it's going to get just even more beautiful. And this will be the last object for tonight, I believe. But
Yeah.
look at that. Look at that.
The last galaxies we were looking at were M95 and 96. And this
Correct.
is M65 and 66
Yeah, here.
at the bottom. And then the Hamburger Galaxy's NGC number galaxy, which I don't remember offhand.
Yeah. Well, we'll go back. We'll go grab it. Yeah. So if we go in here, all right, and look at in our amazing thing here, the Hamburger Galaxy is NGC 3628.
Okay.
Okay. And then this galaxy down here in the triplet is Messier 66. All right. And then this one over here is Messier 65. They're kind of out of order a little bit. All right. But there they are. That's the beauty of this wonderful region of Leo.
Can you scoot over a little bit farther to the right, to the west, just to see 95 and 96?
Yeah, those are right over here. Let me zoom out.
Yeah, right there.
Yeah. Yeah. And we have 105 and these guys, and then we have 95 and 96 down here. And this is another triplet of galaxies, but not nearly as impressive as the Leo triplet itself over here. These 3 galaxies are very well known. If you notice, they're bigger galaxies. Their distances, in part, tell us how far away they are. Just by when you look at them, like this galaxy here, we're looking at a galaxy that's probably a similar distance to this one. And this one is just about 36 million light years away. The Hamburger Galaxy, on the other hand, its distance is something like 45 million light years away. So it's actually a little further than these galaxies. These two are probably close to each other, within reason. Okay, we don't have a distance for this one. I mean, it's out there, yes, but we don't have it directly. So this is the beautiful location. Look at this here. This mess of a galaxy here is probably influenced by this one, because they're gravitationally connected as they are to the Hamburger Galaxy here. And if you look at the Hamburger Galaxy, you can see that its disk is splayed outward at this side and sort of stunted or splayed downward in this side. And as we get more stack images, you'll be able to see that this is this edge right here, this edge of the galactic disk where you see the dust, is really tortured because it goes up over here and it actually has this convolution over here which goes up into here. So it's actually quite a mess. And Dean Bastador, good to see you. Mr. Django says, see you all next time. Gotta go off to work. Glad we're back. Excellent. Thank you very much. And we'll see you later. That's Steven. And by the way, Steven, Mr. Django, put up a photo of his mug that he got from us from our Etsy store. And that was pretty cool. Really cool. You might want to consider joining our Patreon. We've got a number of people that have joined us in our Patreon, and we go. You know, our your support keeps us going. I know it sounds like a public television telethon, but it's actually true. We do have a lot of assistance from folks. That's the way we can do what we do. You know. And I don't take any money for this. Okay? I just, there's no, it's the passion of it. Gladys won. Hey Gladys, how are you? Nice to see you. So, notice the Hamburger Galaxy is starting to get more detailed. And then down here, these galaxies, look at that. Wow. Talk about a tortured galaxy, huh? Look at that. Look at all that in there. This, it almost looks like a tadpole that's been squeezed and squished or something. This galaxy kind of looks relatively cohesive. Fascinating. I mean, who knows? This galaxy is really ripped apart. Probably from interactions with the Hamburger Galaxy, potentially. Izabela, thank you for putting up our Patreon page. Look at that. All right, let's try and grab some contrast here. Bring out a little more detail. We're gonna bring our black level all the way up to the top of this, like that, and then we're gonna actually move this down to soften the noise. And go back to the Hamburger Galaxy now. Look at that. There's a lot going on there. And we pull this back until we stop seeing some of the grain.
All three of them
we
look
need
like
to-
they've had gravitational interactions.
Yeah.
The hamburger reminds me of, I know we've looked at NGC 4565
Oh yeah.
in Coma before. It's an edge-on galaxy like this. It's
Silver
called the
is that
Needle
what that is?
Galaxy, and
Yeah.
you see how different when this one is to 4565 because the way it's fuzzed out at the outer boundaries to either side, it's really been
Oh, yeah.
disturbed.
Yeah, it has. It's definitely had gravitational interactions. You know, maybe you can see how it's flowing down like this, dropping down like this. This galaxy may have actually come close to this one at one point or another. Hard to know. See, we're seeing everything.
65 has a very pronounced
What?
dark lane in it also.
Oh, yeah. Now, if we were to look at this like this without color, it'll come in here in a second. This object here shows up, if it shows without color, then you'll see it as the black and white images of yesteryear might have shown it, you know. And in the research world, when I was doing my degree in astronomy, we often worked with negatives of things. So we would actually work with things that look like this. All right, because if you notice, you can see detail inside the galaxy that, more cleanly, for instance. And so this is an example. See that? Looking at this inverted is very much of a help. So when you go to this, Okay, we bring back this regular view. Some of this detail is kind of lost, but go into the inverted view, and now you can start to see more detail in here that you might have missed in the other shot. Now you can see some of the tortured outer regions of this galaxy, and how this stunted arm is stopped and then curls right in like a 90 degrees almost. And you got this multifaceted structure out here. This is a galaxy in the process of being torn apart. You know, in fact, we would actually look at it like this. We would actually end up looking at it as a full black and white image, which it'll pop in here in just a sec. See, so the black and white images are what we would end up using, because we could actually see the structure much better. Go ahead, Daryl.
What?
Oh, I thought you were going to say something.
If you bring back the hamburger, it looks like somebody put a whole lot of lettuce on that burger.
That's true. Let's see if we can invert this one to see what that looks like. Yeah, you can start to see some of the more detail out there. That's pretty cool.
Michael H., do you mean personal telescope? Vern Trev asks, is this your personal telescope, Mark?
Oh, no, this particular telescope, my personal telescope is actually behind me, but I've actually donated all of my equipment to SkyTour Livestream, our 501c3. This is an artifact of the refresh. So what I have to do, again, Daryl, is just get out of here for a minute and I'll re-share, because I have to bring the screen back to do that, and then I will make it so you can see it again.
Izabela, the hamburger, the cigar galaxy is Messier 82, next to Messier 81 up in Ursa Major.
Mm-hmm. That's really pretty. Well, we got 27, so that's pretty good. We're probably going to get all the way up to 28 here, and we'll stop at 28 with the Leo triplet. All right, so we'll say save right here. And sorry about the online server, but it's back now, so all the files were not lost. They were just queued up, and they're getting uploaded if they're not up already. Izabela's probably looking and has looked, so she'll know. By the way, Vince Giglio, I didn't say hi to you. How you doing, man? That's pretty cool. Yeah, Texas has some storms. I was talking to Alicia Vieras, who lives down there. So she has a prime time seat if it's clear. Yeah, okay. Very cool. So that's it for the Leo triplet, guys. I saved it, and then we saved the image file. And let's get out of that. Here we go. So tell me what you thought of the Leo triplet, guys, and looking at the night sky tonight from Arizona. It's pretty cool. I want to try one other thing here.
Galaxy season.
Yeah, it is. Not quite. We gotta wait a little longer. Because if you notice these lines should be up and down. But we have higher in the sky here. Do you know the coordinates of T? Is it Corona Borealis or Coma? Where this? Oh, it's Corona Borealis.
Yes, what I say.
Oh, okay, yeah, that's all right. No, I don't think you
Yeah.
did.
T
Yeah,
Corona
it's,
Borealis.
Yeah, T Corona Borealis is actually too low for us to look at right now. If we look at the altitude of this, it's way down near the horizon. Here's the eastern horizon, actually. So we can't see it yet. We'd have to stay up until around 4 in the morning to actually see it pretty high up. But as the season wears on, we'll see it.
Oh,
So
I did
I'll
mess up. Yeah. It is Coma Berenices between Leo and Virgo and up between them. So I
No.
misspoke. I apologize.
No, that's fine. Yeah, but it's T Core Bor.
Yes.
All right, that's okay. So yeah, if it was Coma, we could see it, but it's not. Yeah. All right. Well, guys,
My
thank
bad.
you. This was. Now stop. It's okay. No worries, guys. Thanks for coming out. Oh, I gotta tell you what we're doing, by the way. And we're gonna first of all let me park our scope. And get it parked. All right, and I can get rid of this. All right, and I'm gonna bring up this guy. This is my program, and we'll say yes to parking the scope. And you'll see the scope go down into a park position. And then when it finishes moving, we can shut it off. Yeah, that's not. Yeah, that's not where I want it to be.
Oh,
That's okay. I did find that I had to modify the park position before, but that's okay. I can take care of that.
Bonnie's here.
But anyway, guys,
Bonnie's here. She's been lurking. And a hot of
I
77.
can see that. Fantastic. Hi, Bonnie. Well, guys, you guys take care, and you have a good night. And sorry, Bonnie, you just got here, and now we're hanging up. But you've been lurking. You've seen it. But we'll talk to you on the other side when we start this up again. All right? And we're at the backside of the moon cycle, so every sky is a dark sky every night. So make sure you, when you go outside, keep looking up. And we should stream before Monday's eclipse. But if not, make sure you go outside and keep looking up. And on Monday, get your, if you don't have them already, get your eclipse glasses. Okay, and look at the solar eclipse. All right, and only use eye protection when you're looking at the sky. All right, especially the sun. All right, guys, have a good night, and we will talk to you later.
Good night, everybody.
Good night, everybody.